All right. Well, so first of all, as you probably just saw, I record all my lectures. Even though this is a 4-hour class, we usually go for a couple of hours, then take like a 30, 40-second break, and then we take like a 15-minute break maybe, and then we go for the other hour and 45 minutes or so. So I break the recording into 2 separate recordings, and I put them up on YouTube, and then there'll be a link to it in the class. Pretty sure this is the first class you've had with me because I only teach the programming classes in MSIT. I teach in our Masters of CS and then our undergraduate of Computer Science as well. Okay, so let's just talk about the general logistics of the class real quick, and then we'll just kind of dive in. So this is 535. Everybody in the right place? All right, so this is effectively the first computer programming class that we have in the MSIT. We have 2 classes in MSIT for computer programming. The 535 is a required course. 537 is the continuation of this class, and that's an elective course. You do not have to take that one. I think more often than not, the belief of IT students is that IT is not computer programming or doesn't have any computer programming, and computer science is computer programming. The way I look at IT versus computer science is they are opposite sides of the same coin. So I think computer science is about 75% creation, 25% using what's been created. I think IT is about 75% using what's been created and 25% creation. Programming is a core skill set in both of those vocations. The types of tools you might write is going to be different, whether you're in the computer science side of things where you may be writing business applications or video games or things like that. On the IT side, you're going to be writing a lot of scripts, creating user accounts, automated backups, security protocol type stuff. In many ways, the types of programming that you might do on the IT side may actually be more complex than the types of stuff that you'll be doing on the maybe the computer science side because of the tools that you have available to you. On the IT side, you're often going to be writing these scripts in terms of whatever server software you're having to work within, so you don't have really choices. Where on the computer science side, you get to kind of pick and choose what technologies you want to use for the solution to a problem. So bottom line is, if I had my druthers, you'd have to take 535 and 537, but you can only fit so many classes in, so I guess deal with it. So in any case, 535 is our first programming course. I do assume you have had 0 programming experience. I basically assume you've never seen a computer programming language. So if you've already seen some computer programming stuff, you might be at a little advantage starting off, but actually you're going to be at a disadvantage when it comes to the homework assignments. And let me tell you why that is. So first of all, whether you were paying attention up to this point or not, everybody needs to be paying attention for the next 15 seconds. Whoa, you with me?
Yes.
All right. On your programming assignments, this is extremely important. You are only allowed to use the tools that I've introduced in class. Okay? I give these assignments so that there's a reason behind the madness. Okay, so often what I'll do is I'll give you a programming assignment, and it's purposely more difficult than it could otherwise be because you're having to solve it in terms of the tools I've introduced. The next class, I'll show you the solution I expected, and then I'll show you an improved way you could have solved it. Okay, so that's when I'll introduce that next better tool that you in the future may use. Okay, but for that assignment, you can only use what I had introduced up to that point in time. Make sense?
Yeah.
So for those of you who have had some previous programming experience, pay special attention when you're doing your homework. That is, don't start using stuff that I didn't introduce in class to solve the problem, because you're going to get a bad grade on a program that you could have easily solved. More than likely could have easily solved the way I intended for you to solve. But instead, you fell back into the tools that you're already familiar with and just started solving the problem. All right, I get it that you might already be introduced to that stuff. From my perspective as the teacher, I don't know whether you already knew that or whether you found that solution online somewhere. Make sense? So solve the problems in terms of the tools that I provide you with. So when you get a crappy grade on a homework assignment because you use something that I haven't introduced in class, well, don't complain, is I guess what I'm saying. If you're in doubt, feel free to message me or shoot me an email. A good thing would be to use Slack. So while it's on my mind, let me go ahead and introduce that here real quick. If you visit, I usually make this a homework assignment in my other classes, but this class has a structure that I can't change. So if you go to cuwcs.slack.com, so this is the computer science, cuwcs.slack.com, you can go ahead and create create an account right down here. And you can create that account with your cuw.edu email address and pick whatever password you want. That will get you into our computer science Slack channel. From there, you can either use the website, you can download the Mac app, you can download the Windows app, you can download the iPhone app, you can download the Android app. Okay, it's on every single platform you can imagine. And this is effectively a chat tool. So for instance, once you join the Slack channel, so here's our computer science Slack, you'll notice we have a whole bunch of classes in here, and one of those classes, oh, well, I better create then. Must have got archived. So we have a class called 535. So I'll go ahead and create that channel. It's a public channel. So now you should be able to go ahead and join that channel. All right, and I'll go ahead and I'll star it. That way it's up top on my list, since I obviously have access to a lot of channels on here. So if you ever have a question, everybody should join this 535 channel so you're in here. I'm going to assume that anything I put in here, you'll see. If you get the iPhone or the Android app, you'll get a push notification as if it was a text message. Okay, you can set up notification settings in there and stuff. Otherwise, check on this stuff. So if I get a question about the homework and I need to clarify something, I won't shoot out an email blast to the whole class. Instead, I'll post it in here. Okay. Similarly, if you have a question about the homework, you can either direct message me on here. You can send me an email if you want. Or if you think that the question is something that other people in the class might benefit from, ask it publicly. And I'll reply to it, or one of your classmates might reply to it. Now, having said that, in terms of academic dishonesty on homework assignments, programming assignments are difficult. Okay, I know we'll talk about that today. We're going to spend a lot of time today talking about the history of programming and kind of what computer programming is and things like that. I don't have a problem with you working in groups on your programming assignments. Okay, having said that, when you turn in your assignment, I want it to be your own work. Okay, so don't have one copy of the homework and have 3 people put their name on it. Okay, if you want to work together, and that'll help the people who are a little bit stronger can then help the people who are a little bit weaker, and that'll make the stronger people a little bit better. That's fine. But I ultimately want you to submit your own work. I'm going to find out on the final exam. The final exam is going to be primarily programming. So if you've been riding somebody else's coattails, when you get to the final exam, it's not going to go well. And since you need to get a B- or better in the class in order to continue on through the program, it doesn't matter how good your homework grades were up to leading up to that point if you bomb the final. Okay? And we'll talk about how the grade breaks down here in a few minutes. But in any case, I do encourage you to work together on the programming assignments, not on the papers. On the programming assignments, because it is good.
If we are doing like 2 or 3 guys doing program together, it will seem like it will look similar to.
Similar is fine. Like I said, I'm going to find out on the
comments will be different, but
that's it. I'm going to find out at the on the final exam. But I don't want to see is that if all 3 of them have the exact same syntax error, all 3 of them, they could. I want you to turn in your own work. If you are submitting something and you think it might look closer than it should, shoot me an email. Just say, hey, I worked with these 2 other people on this. Just wanted to let you know. I'm not going to sit here and hunt for cheaters. Like I said, I'll find out on the final exam. Okay? So I want you to collaborate on the programs, but collaborate with the goal of learning the material, not with getting the homework done, because it's going to bite you on the final exam. All right, so if you're going to work together on it, that's fine, but try to learn the material and maybe get with somebody who's a little bit stronger or something like that. All right, so that's programming assignments. That's Slack. So programming assignments, like I said, I'm okay with you collaborating on those as long as you make every effort to turn in, something that is original work from you. I understand there's going to be overlap when you guys are coming up with a solution yourself, but do yourself a favor and try to learn as much as you can from the assignments. Papers should be done independently. Okay, so I should not see any duplication. I should not see an entire paragraph that's identical between multiple papers. I'll hit you pretty hard on that one for cheating on papers. We have all sorts of tools that compare them to each other. Similarly, copying from sources online, I do realize some of the papers being technical type documents are going to, sometimes you're going to find a resource online that pretty much says what you want it to say. Now, if you really feel like this chunk of text is something that needs to be in your paper, fine, copy it, quote it, give me a reference or whatever. But generally what I'd prefer to see is for you to just reword what they said in your own words so that I at least know that you read it. Okay, that you at least it went through your brain at some point. You tried to process this into some knowledge. Okay, so don't collaborate with each other on papers. I have systems in place where I can see that it's bad. So that's not going to bode well for grades on papers. Similarly, we have an accreditation here. So every single week, you're going to have a programming assignment, and you're going to have a paper, a writing assignment. Okay, that's required for this course to meet the IEEE standards for accreditation. So that's good for you from an accredited program perspective, bad from you from it's going to be a lot of work perspective. It's a trade-off. Now, having said that, the other thing I'm going to nitpick on, I'm not going to nitpick on like a missing comma and stuff like that on grammar. All right, but given that a majority of you, English is not your first language, your paper should not read like broken English. All right, so that means that I highly, highly, highly encourage you to take your paper after you write it to the writing center and have them look at it. They'll give it a read through. They'll say, okay, it needs to read this way in order to fix some of these problems. That way you can fix it. Might as well catch the 20% you're going to lose there than let me grade it first, and now you're sitting at an 80 as your starting point. Make sense? So take advantage of the writing center. It's going to save you 15 to 20% per paper. All right, and that's going to be important when you need to get a B- or better in the class. Okay, I'm not going to nail you on grammar like, oh, this is a run-on sentence or a missing comma or something like that. I'm really looking for the content of the paper and does this read reasonably? Because so I guess the filter I'm letting it go through is if I am working in industry, okay, and you're an employee there or something like that, and I've gotten an email from you, I should be able to read this and not and feel like the person on the other end is competent. That makes sense? All right. So one of the skill sets that you need to have as an IT professional is written communication. All right, so it's going to be very important that these read that way. That's going to be the lens that I'm going to be reading them through, is whether or not this comes off as a competent paper or whether this comes off as something that we just kind of slap together. Okay? So, questions on that? No collaboration on the papers, though. Individual papers. Okay, so here in the syllabus, my office is right there, S112. It's a couple doors down. This is my cell phone number. You can call it if you want, but I probably won't pick it up. The fact that my cell phone makes phone calls is an added plus. But if you do need to text me or something, you're running late or whatever, that's fine. Feel free to text me. Also message me on Slack or email me. Those are the best ways to get a hold of me. All right, let's see. The rest of this is fluff, fluff, fluff. blah, blah, blah. Learning outcomes. Okay. Grade breakdown. So every single week, like I said, you will have a programming assignment and you will have a writing assignment. Programming assignments are worth 40% of your grade. Writing assignments are worth 40% of your grade. So from your perspective, you can just assume assignments are worth 80% of my grade. Okay? Final exam will be on the last day of class. It will be about a 2-hour exam. And it will be and we'll talk about it the week before, kind of, what kind of things you can expect from it. But it'll be largely a computer programming exam. So anything that you haven't gotten out of these programming assignments, I'm going to find out pretty quick here on this final exam. Make sense? All right. So that's the grade breakdown of the course, and that's your normal 90, 80, 70 grading scale. Okay. So questions about the class in general from a grading perspective and the homework perspective and the cheating perspective and all that other crap.
So we don't have any midterm or something?
No midterm. Nope, just the final.
Assignments.
Yep, final and a bunch of assignments. So you'll have 14 assignments and a final exam.
Like the 2 assignments are already visible to us, so every week when we have class, the next set of assignments.
Correct. Yep. Every week I'll give you the next set of assignments. Okay.
About grading assignments.
Mhm.
What's the lag time on grading assignments?
You'll have it. The grade will be back before the next class period. Usually, I'll have them graded before that weekend. So if we have class on Wednesday and you have it submitted, if I don't get it in by Saturday, chances are I'll grade them on Saturday morning.
I thought you were getting grades 2 weeks later or anything like that.
No. Worst case, you'll have your grades before we meet next. Minus like a car accident or something like that. But yeah, so has that been a problem?
Sometimes, yeah.
Really? Oh, okay. Well, you'll get your stuff will be back relatively quickly in here. There's usually more of a lag on online classes, has been my experience, just because we have so many different students who are at different stages. But with an in-class thing, it seems like it's easier just to grade them all at once when they come in. So yeah, I don't know what to say. Okay, other questions?
The day before the next class is the deadline for the submission of assignments.
Day of. So your assignments need to be submitted by 6 p.m. the day of the class. So I'm going to expect the timestamp on your paper and your programming assignment for next week to be by 6 p.m. next Wednesday. So that's considered on time. Now, having said that, I also do not accept late work, except in very dire circumstances. Part of the reason for that is I solve every one of the programming assignments in class. So when we come to class, like I mentioned a little bit ago, I'm often giving you an assignment with the understanding that you're kind of being forced to solve it in, let's call it the bad way, using only the tools I've introduced. So beginning of the next class, I'm going to solve it the way you should have solved it for your homework, or something very similar to the way you should have solved it. Then I'll kind of upgrade your skill set and show you an improved way of solving it as we kind of move towards the next skill set you're going to need for the next homework assignment. That kind of stuff. Make sense?
Will there be quizzes, sir?
No quizzes. No quizzes. At least it's not going to be part of your grade. I suppose I reserve the right to give you a quiz, but there's no place for it to be a graded event. Yeah, I guess it's entirely possible if we get into a situation where I'm really struggling to understand what people know and what they don't know, I might give you a quiz, but it would be more for my information, where the deficiencies are as opposed to a graded event. Something like that, because there isn't a grading spot for quizzes. Anything else? Good? Okay. So let's go over to here. Close this. Enough. All right, and like I said a little bit ago, I do record all the lectures. You can go back and rewatch these when you're working on your homework and stuff like that. I also, as you just saw me start, I create a slide set for the class, but it grows as we go, because sometimes different classes we're going to take some different turns and stuff based on what questions come up. I will also share these, so you'll have a link to the slides on Blackboard as well, so you can view the slides online and that kind of stuff. If for some reason they're ever not working, just post something on Slack and I can export it to a PDF and throw it on Slack until iCloud acts better. You know, I know Apple never has problems, but sometimes it does.
So we are going to have these videos on Panopto?
No, I don't use Panopto. It's crap.
Oh, yeah.
Yeah, no, I use YouTube. Yeah, they'll be on YouTube.
So do we have a link on Blackboard or no?
Yeah, as soon as I upload the first set, I'll put a link up there. Yep, because right now we're only what are we? We're 20 minutes into the first recording, so nothing to link you to yet. But yeah, I create a playlist so you'll be able to get to all of it. All right, so let's go ahead and dive in. Out of curiosity, how many of you have ever had any programming experience at all in here? Okay, what have we done?
A little bit of Java, a little bit of C++, DB scripting.
Okay.
HTML, CSS. I mean the whole.
Okay, what kind of stuff did you do with these things?
Web programming, server administration.
Okay.
You know, account scripting, directory programming.
Okay.
Exporting, stuff like that. Reworking, re-engineering programs sometimes if we need to.
Okay.
More of a hack than anything else.
Gotcha. Okay. Who else has had some programming stuff?
I have studied like BTech Computer Science. There we study all these C++ and Java and Pascal and things like that.
Okay.
And we implemented it, but not much in similar like web developing. And most of the times we were like, if there is a problem, we were trying to find a solution, and we usually sometimes we go to source code and copy stuff sometimes. And
Okay.
sometimes think about like reshuffle it and do things like that.
Okay.
So that was all.
What kind of programming have you had?
C++ and Java in undergrad. It's just assignments and homework.
Okay. And one other person, I think?
And I worked as Java developer in MNC.
Okay.
I worked on applications development on scripts.
Okay. We're going to be using Java in here as our development language. I'm of the opinion that all programming languages are the same. The reason we use Java is because I don't have to worry about what kind of computers you have. So Java, the development tool we're going to use is called Eclipse. You can get it for Mac, you can get it for PC, you can get it for Linux, you can get it for your toaster. It works for all those things. Just to point out, every single one of you who said you've had some programming experience mentioned Java. So pay special attention when you're doing your homework not to use things that we didn't introduce in class. Okay, in case you were previously introduced to some things that likely would help you, and I likely will show it to you the next class, but that wasn't the intention for the homework assignment. Okay, so again, like I said before, I like to approach this class from the perspective of you don't even know what computer programming is. Okay, so I'm going to start with a zero understanding, and we're going to kind of build it from there. So having said that, let me, I like to start this off by asking, how do humans solve problems? And something I usually ask the first day of class, I'll ask, something like, how many of you got to class today without bumping into any walls? Hopefully most of you, right? Y'all got here without slamming into a wall, slamming into other people, something like that. You usually get one or two smart asses who say, it's like, oh yeah, I bumped into anybody. But what's amazing, I sit here during the daytime when the halls are super crowded with all the undergrad students, and not only are these people getting to class without hitting walls, it's not even worth their time to look in front of them. They're texting while they're walking, right? They're bobbing and weaving in and out of people, no big deal. Okay, so you got to class today without bumping into anything?
Yeah.
No. How did you do that?
I woke up early, go to office, and then straight to my here.
Okay, so so when you came in from the parking lot and you were walking through the halls, even though there weren't a whole lot of people to dodge, you claimed that you missed all the walls. You didn't bump into any walls.
Almost not.
Okay, well, so how?
Yeah.
How did you miss the walls? What strategy did you put into play
I
to?
had like nothing in my hand. My phone was of course, like.
Okay, so you were paying attention.
Yeah.
Okay, gotcha.
And I was looking around.
Okay, so you just kind of scanning the area and then just hoping.
No, not hoping. Just I was scanning around and walking straight.
Okay. Now, were you confident before you walked into the building that you were going to miss all the walls, or was this something you were concerned about? Like when you were in the parking lot, were you thinking like, oh, I hope I missed the walls this time? That didn't cross your mind, right?
No.
Okay, so punchline is we all got here today without bumping into too many things, unless it was a little mistake, right? Okay, and it wasn't something we stressed about. It wasn't something we were worried about as we were coming in from the parking lot, because it's not a big deal to us, right? It's like, oh, why is he asking me if I bumped into any walls, right? Now, the reality is now all of us walked in from the parking lot today. So we just walked from the parking lot. Okay, how do you walk? Teach me. If you were to explain to somebody how to walk, what would you tell them?
Just be straight, raise your right foot,
Okay.
and keep it straight, and keep it on the. Next to it, keep it on the earth.
Back than that. I mean, you're assuming that you're standing already. I mean, you got.
Okay, so
How do you?
Yeah.
all right, so how do I stand?
That's another
How do you
perspective.
stand? What position are you in to start with? I mean,
Okay.
You know, you gotta.
So we got to figure out what's our starting position so we can get into a ready to walk position.
Yeah.
Okay, fair. Okay, so now I'm in a ready to walk position. Now what? What's my next go-to move?
Well, first, like you were saying, but I think you have to think about before that is it even safe to start walking?
Okay.
You know, what's my environment like? I mean, am I walking in the lava or am I walking on ground? Or,
Okay.
You know, what's the surface I'm walking on?
Okay.
You know, how I'm gonna walk is gonna be different on ice versus.
Okay, so we might have some different walking techniques.
Yep.
Okay. So I'm going to use my standard walking technique on a non-slippery surface.
Well,
So what's that look like?
back straight. Are you left-footed, right-footed? No, yeah, you have to make that determination.
I think first we have to make it sure that we are holding the ground with one foot tight.
Now, so tell me, how many muscles in your legs take part in the walking process?
Probably, I don't know, in each leg, probably a dozen muscles.
Okay, so a bunch of muscles. And I assume as you're walking, you think about each and every one of those individual muscles?
No.
You think about contracting each one, and
I think
that's not cross you. How do you pull it off?
it happens automatically.
Automatically, okay.
But it didn't happen automatically. I guess what I was getting at is, I mean, we were all babies once. We all had to learn those processes. It took a long time to teach your muscles how to do that.
Okay, so you're saying you spent hours and hours and hours studying this walking thing.
Well, I don't know. I was a baby at the time. So
Well, right, but so you suspect that that's something that happened. So there was hours of practice and trial and error. And so you should effectively have a PhD in walking.
pretty much, I think everybody should, yeah.
Okay. So why is it that you can't articulate to me how you walk? This is the trap. All right, so here's our punchline here. So I like to think about how human beings solve problems in general. Okay, and I break it down into 3 little steps here, and you'll see why here in a few minutes. So I think we use our memory, we ask questions, and we do repetition. All right, so generally speaking, human beings leverage our memory, our ability to ask questions, and repetition to solve problems. So as we're walking down the hall, well, first of all, we got to remember where we're going. We got to remember where our feet are. We got to remember about these muscles somehow. We kind of already talked about that. There's a kind of a fogginess there at some point, as a 8-month-old or something like that. We must have been, hitting the, I don't know what it, hitting the baby food a little hard or something, because we seem to have forgotten some of these details that we just take for granted now. But as we're walking down the hall, you pointed out, we're constantly asking these questions. Am I going to fall down? Am I going to fall down? Am I going to hit something? Am I going to hit something? Am I going to hit someone? Things like that. And I assume every one of you, as you're walking down the hall, you hear yourself asking every one of those questions constantly. It's just annoying, right? We believe we're asking them, but we don't really recognize we're asking them, right? So when you were walking down the hall, you didn't hear yourself ask the question, am I going to fall over? Am I going to slam into a wall? We didn't hear ourselves doing that. But we all believe that at some level we're probably, looking at our surroundings and taking measurements, if you will, right? Okay? So we're asking a lot of questions. And then there's certainly a repetition aspect to this where, we're kind of repeating the same pattern over and over and over and over again. All right? So now, let's try to give a definition to computer programming. What would you say computer programming is? Just give me your best guess. If you had to define computer programming, what would you say?
So that's step-by-step procedure to solve a problem.
Okay. Seems very boring, that definition.
Yeah. To me as well.
If you haven't noticed yet, my class is a little bit more interactive than maybe some of the other ones. Is that true? Aren't these other classes kind of boring? I couldn't stay awake through Dr. Locklear's classes. Remember, I record everything.
Write something only the way computers understand it.
Okay.
Program. Language of computers, to write something which computers can understand.
Is it fair to say that computer programming is to tell a computer what to do?
It's used to perform a task.
Yeah, we're trying to tell a computer what to do. Tell a computer what to do. That's computer programming. All right? When we're dealing with other people, I might say, hey, would you get me a soda? All right? We can use English or one of our natural languages to express that to another human being. We're good at that. We're used to dealing with human beings. Okay? But now we have this alien thing. Okay? This computer that's not like a person. It's, we can say it's dumb, but at the very least, it's very, very, very different. Okay? Computers don't think like we think. Okay? So for us to tell a computer what to do is a task. Because this interface is different. I'm not talking to a human brain. Okay, it can kind of fill in the gaps. It can figure out what I meant, not what I said. All right, so computer programming, we're going to say, is the act of telling a computer what to do. So now we need to talk about the tool that we leverage. What's our sword? Okay, that's a programming language. Okay, now what's the job of a programming language? Okay, well, so it's our tool. So think of the programming language kind of like the sword we're going to use. All right, it's this tool that we use to communicate with this guy. So it's kind of a walkie-talkie, if you will. And if we talk through this guy, it somehow is able to turn human way of doing things into the computer way of doing things. Okay, so a programming language attempts to emulate the way humans already solve problems, such that we don't have to change too much. Instead, the language does most of the translation. All right, so it allows us to continue to solve problems like a human being would solve problems. And the language then gives us that leverage we need to ultimately convert that into something that our computer can understand. Okay? It's not going to go all the way. Notice I said it doesn't make us change too much. We are going to have to adapt, okay, our way of solving problems a little bit. And the reason why is this next slide. The problem. Most beginning computer programming students would be of the opinion that computer programming is hard, okay, that it's difficult. and we take our, take some of these really complex pieces of software that are out there. Pick your favorite video game like Battlefield or Call of Duty or something like that, with some game with lots of explosions and stuff like that, lots of things happening on the screen. We can imagine that whoever wrote that must have been a genius. And that was a really complex thing to solve, and that's hard. That's a hard program to write, correct? Okay. Writing that program is absolutely trivial compared to whatever every one of you did walking in from the parking lot today and missing every wall. All right? The problem is not that computer programming is hard. Computer programming is actually trivial compared to the types of problems human beings solve on a daily basis. The problems we solve as computer programmers aren't nearly as complex as the problems we solve as humans. They can't be. We don't have the tools to be able to make them that complex. We really ask our computers to do very boring, trivial things. The real problem here is that humans are so good at solving problems that we have trouble articulating how we solve them. A couple minutes ago, I asked you to articulate how to solve a task that every one of us does every single day, multiple times, and we've been doing it for years and years and years and years and years. Okay? This guy over here told me he has a PhD in walking. So, punchline here is that many of these problems that we take for granted, that we know we can solve, we can't spit out how we solve them. The most accurate thing we can say is, we just do. That makes sense? Okay. Now, just to kind of put that in context for us a little bit, how many of us have seen, whether it's on the YouTube or TV or something like that, some of these robots that are able to walk up and down stairs? Seen those things? Or I think somebody made kind of a robotic deer-looking thing that could run on ice and that kind of stuff. So different robots that could do things like this, right? So does that mean that somebody, maybe some group of really smart people, sat down and actually taught that robot how to walk when you couldn't tell me how you walk on a daily basis? You couldn't explain to a human being how you walk. Yet we need to tell the computer how we're going to walk. Did they teach that robot how to walk?
I think it depends.
Okay.
The reason why I say that is it depends on the type of robot. So if you're talking like maybe a biped robot, they would probably have to teach the machine based on its parts. They may have a subroutine that says pull this servo, do this servo, do this servo,
Okay.
and so on and so forth. And they have to teach each of those parts on how to react. So they probably
So those are kind of like the muscles, right?
correct.
Contract this muscle, do this, okay.
All right, and then they probably treat that section to work on its own, like a subroutine
Mm-hmm.
that does this. So whenever this happens, this subroutine triggers, or whenever this happens, this subroutine triggers. So then that's how they probably break it down in pieces.
Okay.
In that aspect, and then teach it that way. So it's probably broken down into those subroutines, and then they have a bigger routine that triggers those subroutines. Does that make sense?
Sure.
Okay.
Okay. So at the end of the day, after they've, basically modularized the solution, as you're kind of pointing out, have they effectively taught it how to walk? I mean, do you think that's what they've done? Have the people who wrote the software for those robots, have they actually thought about the problem enough where they have broken down the act of walking in terms of the program, in terms of the robot's legs? So our legs have 50 muscles in them, let's say. I don't know how many muscles are in our legs, but a bunch of muscles.
14
Yeah.
PhD.
Okay. Oh, that's right. Okay. See, he could be making that up. I have no idea. So, in any case, the robot, maybe we kind of know it has maybe 6 moving things that are attached to servos and that kind of stuff. So it's solving the problem in walking in terms of those moving parts on the robot leg, not on the human leg. But do you think outside of that, is it still capturing
No,
all the little steps that go into walking?
probably not.
Okay.
On terrain surfaces, it follows like those machines. Even in DARPA competitions and things like that, when they just make these machines walk, they do not when they make them to climb the steps or do some terrain surfaces.
Okay.
They fall. They do not stand at
And
that
I-
time. Like
And I
on
tried,
that extensive programming.
yeah, because you, in theory, you think you taught it to walk, but I think what you're missing is the difference is we know how to walk because of our senses. We have that extra input.
Mm-hmm.
We know that that's not a good step. We're not going to take it.
Mm-hmm.
The machine is not going to know that it doesn't have the senses to determine if that's a good step or not, unless you have added attributes
Mm-hmm.
to that robot to determine, and analyze or figure out how to analyze
Okay.
that and then put that into legs. Oh no, you can't quite step that way. You got to half step that subroutine or
Mhm.
something. That's where you're going with it, right?
So, and actually,
Yeah.
that's really good. So, what you're kind of capturing there. So, the reality is the way these robots work, the ones that you've seen walk. Actually, let me see if I can trick you guys again first before I tell this punchline. So, we're going to train one of these robots that we've seen. It's going to walk, down this hallway and then up like a very uniform set of stairs. All right. And let's say you watch the robot walk up and down this path here it's nice and smooth, and then we have a little staircase that's very uniform. Each step is the same depth and all that stuff, and you see it successfully walk up that staircase, turn around, come back down that staircase. Okay. Now I'm going to point over here. I'm going to say, okay, here's our treacherous pathway leading to a treacherous staircase. A less uniform one. Okay. Not death trap, but less uniform. Do you like that robot's chances? Okay, you don't like the robot's chances, right? Probably just because it did so well on the ideal circumstance that it's probably not going to do very well on this one, right? The reality is it probably will do quite well on this. Okay? And the reason is because of the way the problem is actually solved, and it actually is solved in terms of all those extra sensors. Those robots haven't been programmed to walk. They've been programmed how to not fall. All right, so what they do is they have all sorts of gyroscopes and accelerometers, and they use cameras for detecting uneven pavement, various sensors, just like human beings use. Okay, and what they do is they haven't solved the problem of how do you walk. Instead, they put themselves in a scenario of being off balance and then write subroutines, as you pointed out, on how to catch your balance. If you're leaning a little bit too far to the right, what do? You put a little bit more power into your right leg to push you back to the left, but not too much, otherwise you'll go too far to the left. So those robots have learned, a lot of times it's through neural networks. It's an artificial intelligence type of approach where they basically put them in off-balance situations over and over and over and over again until they catch their balance right. And then they say, good boy. And then they reinforce that.
The way you're explaining that, put it in our terms, we're thinking we're walking based on we just learned how to walk.
Mhm.
But in reality, we probably use that same logic.
Absolutely.
How do we prevent ourselves
Yeah.
from falling?
Yeah, what's that first move when a kid starts walking? Usually they pull themselves up in some situation where now they're forced to stand when they've never been in that position before. Usually it's a fall over, but sometimes they last for 2 or 3 seconds before they fall over. And, then 2 or 3 seconds turns into 20 or 30 seconds and so on and so forth. So it's kind of a trial and error type thing where they learn how to keep themselves from walking. So what does it mean for a robot to walk forward? Well, the person at the controls basically says, okay, well, I ultimately want to get here. The way to get there is to lose your balance forward and don't stop moving until you've reached some destination. Okay, now stop yourself from falling. Okay, we're going to keep leaning forward, trying to fall, but now you have to stop yourself from falling. All right, so that's kind of how those things work. So these robots that we've taught how to walk aren't actually walking. They're actually just not falling. Okay, and that's really what we're doing as human beings. Would it be fair for us to say when we're walking down the hall, we're effectively losing our balance forward, catching ourselves, and then doing it again over and over and over again. And we try to do this as smoothly as possible so that we're not twisting ankles and things like that. So through practice, we've made it look like it's on purpose, even though we're basically a walking death trap as we're coming down the hall. Make some sense? Okay, so the issue we have here, so understand that's a different type of problem solving, that artificial intelligence thing. We're not unambiguously articulating the solution to how to solve a problem. Instead, what we're doing is we're trying to recognize patterns. In that case, the pattern of not falling over, for example. And like the first artificial intelligence neural network I ever wrote was years ago in grad school. And it was we wrote a neural network that, and we trained it on the 1 through 5's multiplication table. So we basically fed it flashcards. So what's one times 7? What's 2? What's 1 times 3? What's 2 times 3? What's 3 times 3? What's 4 times 3? So on and so forth. And we kept adjusting it. There's all sorts of algorithms we can use to just adjust this neural network until it got 100% of the answers right between the 1 and 5's table. So you have this network of things kind of mimicking the brain, let's say, and it's basically been just balanced to the point where it guesses perfectly for the 1 through 5's table based on the inputs. Then we fed it the 6 through 10's table. How do you think it did? It was perfect at 1 through 5. We balanced this thing at solving the 1 through 5's table perfectly, 100% accuracy. Now I fed it the 6 through 10's multiplication table. Do you think it did well, or do you think it did poorly?
It should do well because it is already
Like 97%. It had never seen that information before, but it had captured the pattern of multiplication. So kind of fascinating, right? That those kind of things exist. So a lot of these kind of amazing robotic things we're seeing have a lot more to do with that kind of problem solving as opposed to algorithmic problem solving like we're going to be talking about in here, where we are unambiguously specifying the solution to a problem, like a recipe. Okay, you don't unambiguously bake a lasagna, right? We don't learn the pattern of making a lasagna. We instead, here's the ingredients we need. Here's the amount of each ingredient. Here's the order we put it in there. This is what we do in between each step. All that stuff. These are very important that we follow. Over time, you might learn little tweaks that are more experiential to make the lasagna come out a little bit better than it would otherwise. But, somebody doesn't say, get cheese and lasagna noodles and now you make a lasagna. That doesn't work that way. All right, so at the end of the day, our big problem that programming languages have to fight is this idea that humans are too good at solving problems. Okay? So much so that we have trouble articulating those solutions. So right off the bat, we are limiting ourselves to the types of problems we can solve with our computers, because we can only solve problems that we are capable of articulating the details of the algorithm to, the recipe for solving. That makes sense? So either we need to get better at articulating those things, or we have to start leveraging other things if we want computers to be able to mimic us. That's where this robotic artificial intelligence stuff comes in. It's a different way of solving problems. All right, so we're going to say this is our problem. And no matter what we do, even with the PhD in walking, we still can't articulate walking. So we're not going to be able to tell a computer unambiguously how to walk. It's going to have to capture that concept some way else, some other way. Therefore, for us, we are limiting ourselves to the types of problems that we can articulate. But even saying that, we still, as human beings who are not yet programmers, still lack that skill set in turning even some of our most basic solutions into unambiguous step-by-step solutions. So we still have a weak skill set in this, even problems that we could articulate. So for instance, I just mentioned something like making a lasagna, okay? Or making a grilled cheese. So let's go a little easier. So making a grilled cheese. Most of us probably feel like we could give another person step-by-step instructions for making a grilled cheese, right? Or a peanut butter and jelly. Pick your, if you don't want to deal with the heat, pick your poison, I guess. But the reality is we would really have to think about it pretty hard to make sure we didn't leave any little tiny steps out. Things that maybe a human being would take for granted, but that we actually need to fill in those blanks for a computer. That makes sense? That's the practice that we need to learn computer programming as a skill set. How do we turn if a human being would need 4 instructions, how do we expound that into the 7 or 8 instructions that a computer would actually need to accomplish the same thing? Those little tiny steps in between the steps, computers are going to need. Okay, so we do need to get better at articulating the solution to problems, even the ones that we know how to articulate. All right, so that's our problem that we have. All right, so humans solve problems this way. We want to talk to a computer. The computer programming language comes to the rescue somehow to let us talk to that computer. The problem the uphill battle that programming language is trying to fight is this battle that we're too good at solving problems. Okay, and human beings can only adapt so much. So I'm going to copy this slide. I like to call this one the mapping. 100% of programming languages. A few minutes ago, you heard me say something along the lines of that all programming languages are the same. Okay, and they are. My research area is language theory. So I teach our classes here on writing programming languages from scratch, and I know a lot of programming languages. On a given week, I teach in many different programming languages, and it's all the same crap. Sometimes I'll be teaching a Python class, teaching a student in Python, and I might still be in Swift mode. So it might take me a few minutes to kind of say, that's Swift syntax, this is how you do it in Python. Or that's C# syntax, this is how you do it in Objective-C. It's all the same stuff, just each one has different words to it, okay? So, and this is actually a relatively unique audience in our graduate programs that can uniquely understand this. Most, my undergraduate classes, a majority of our students are American students, right? Okay? Most of you in here speak at least 2 languages, right? So you're uniquely qualified to agree with me on this, that when you're talking to your friends who speak English versus when you're talking to your friends who speak in your native tongue, the exact same problem solving is going on in your head. You don't think differently. You speak different words. The syntax is different. You use Java versus Python, but you're problem solving in the identical way because you're talking to a person. That make sense? Same thing's true here. When we're talking to a computer, we problem solve the exact same way. Doesn't matter what kind of language we're leveraging. Certain languages might lend themselves to certain problems over other languages just because they were maybe built with a specific problem in mind. Okay? But generally speaking, if we are talking to a computer, that problem solving, this programming as a skill set problem solving, does not change when we're working in one language versus another language. Okay, so when students ask me, well, what's a good first language to learn, or what I find funny, especially when this is like seniors in computer science undergrad, when they say, I'm good at Java, I just can't figure out C#. It doesn't make any sense. You want to just kind of slap them around a little bit. It's a nonsensical statement. Those are actually the same language, literally the same language. You could take a Java program and it will almost compile in C#, as is. We'll actually talk about why that is today as well. So programming languages are all the same. So believe that as you're getting into this. So for those of you who have some background in other languages, the good news is that once you get to the point where you feel that you have an advanced skill set in programming, you can apply that advanced skill set to any new technology that comes out. Okay, if you want to go and learn iOS development with Swift or Objective-C, you want to learn Java or Android development with Java, whatever, doesn't matter what you already know. If you're already an advanced programmer, you can go and do those things. Okay, so I call this guy the mapping. 100% of programming languages, literally 100% of them, will have facilities for these 3 things. Every single programming language will emulate memory, usually through something called variables. 100% of, I'm going to do little arrows instead of equal signs, just because I feel like arrows. 100% of programming languages will emulate asking questions through conditionals. Usually these are if statements, and we'll talk about why here in a few minutes. And they emulate repetition through loops and functions. 100% of programming languages will have mappings for these. If it doesn't have this, it's not a programming language.
Every language has a different, there are different variables to define.
Maybe different variable types, but they all have variables. They all have a way of remembering a value associated with a name.
Yeah,
A
the
name value
problem
pair.
solving is similar. Problem solving is
All of
the
them.
body of the program is always similar. But
Yep.
how to define variables and
All right. You ready for me to trick you again?
always.
He's got a PhD in walking, but I have a PhD in computer science. All right, so we went down our list here. So several of you mentioned you've had some programming before. So I heard some of us know Java. What other languages do we know? C++. What else?
C#, C, or .NET.
Okay, so .NET crap.
Yeah,
Okay.
that was pretty old.
ASP, Perl.
Okay, ASP. Oh, got a Perl guy. We're going to talk about Perl here in a few minutes. Okay, what else? You haven't fallen in my trap yet.
Python.
All right. Okay with that? See, what I did is I probably shouldn't have taught that previous slide before I asked this question. See, he technically fell in my trap earlier, but he didn't know he fell in it because I hadn't posed the question yet. He's asking what languages that you've done, and you kind of went through your languages, and you mentioned HTML and
Yes,
Yeah,
yes,
but
yes.
I did, but those are not really languages, they're just interpreted, I mean, they're languages, but
they're not programming languages. Yeah, they are languages. Yeah, so these would be languages. So we'll pretend like you all fell in my trap. Okay, we can do Ruby. Oh, you want to say on Rails? That's a little bit of a trap. Ruby's the language. Rails is something else. We'll talk about that. All right. So
in that case, Perl would technically be a language.
Perl's a language. Perl's a programming language, full-fledged. It even has object-oriented things later on. Yeah. Not programming languages: HTML, CSS, XML, JSON. Let's leave it at that. It's good enough for that example. Okay, so these guys are not programming languages, so that must mean they're useless, right?
No.
All right, so I usually refer to these guys as data representation languages. All right, we'll talk about that here in a second. These guys would all be programming languages: Java, C#, C++, C, ASP. Then you also have ASP.NET in here because those are actually two separate technologies. Perl, Python, Ruby, not on Rails though. Trap. All right. So these are data representation languages. So what's the point of our data representation languages? Well, let's talk about that. So one of the things we're going to accomplish today is we're going to try to understand the world of technology from a networking and computer programming perspective, so that all of these buzzwords that we've all, that many of us have heard of. We just kind of had a little small screen of buzzwords right there, though, but there's other ones that we're aware of. We just don't necessarily know what they mean. We want to gain an appreciation that all these buzzwords actually all fall into like 4 or 5 different categories. They're all the same crap. Okay? There's 8 or 9 different ways we can solve this exact same problem. So you just pick your technology. And what's the reason you're picking this technology? Well, maybe because it's compatible with this other technology that was either picked for you or that you already picked. Okay? So we're going to talk about this generically and then get to the more specific first. So we're going to talk about client-server programming. Well, client-server just infrastructure. Okay, so in the client-server model, the client comes in and requests something from the server. In kind, the server responds with an answer. That's the client-server model, right? Okay, and we deal with this all the time. Okay, if you walk into a McDonald's, The client walks into the McDonald's, walks up to the server and says, I would like a Big Mac. The server somehow magically produces a Big Mac, throws it at the client, and now the client has received the response to the request. That's the client-server model. All right. Now we want to think about this in our, this is the first example here, in the web world. Okay, we have our web client and we have our web server. Who's the client? Who's the web client that talks to a web server? Browser. So this is our web browser. That guy. And this is our web server. Okay, web browsers make a request in what format? You may or may not know this, but I'll figure I'll ask anyways. What's the nature? So I'm the somewhat drunk McDonald's patron that walks in and kind of babbles in English that I want a Big Mac. What is the web browser? How do they make that request? What's the nature of that request they make to a web server? Okay, well, it would be done in something called HTTP. Yeah, HTTP, this is the Hypertext Transport Protocol. What that is it's the language that web browsers speak to web servers. Just like I'm speaking English to you because that's the only language I know. All right, so web browsers know HTTP. Web servers agree to speak HTTP, so that's the language that they speak to each other, okay? The channel over which they speak that is a TCP IP. It's TCP over IP, which is a whole different thing. So when you take the networking course, you'll learn about that. How many of you have had the networking course? Anybody? You didn't have the answer? Who taught your networking course?
No, I have taken in engineering a little bit about networking.
Okay. Did you have the networking course here?
TCP/IP.
Then why didn't you know this answer? Who taught the course? So she doesn't want to say. It wasn't me, though, was it? I didn't teach the class. No. That was Hobby. Who? Oh, he's good. Yeah. You didn't learn HTTP in there? All right. In any case, we make a HTTP request. Web server receives that request, does something with it, and ultimately spits what out to the web browser?
The interpreted HTTP response, which is going to be in HTML format, if that's what it was requested.
Yeah, if we're dealing with web browsers, it definitely would be. But now web servers start talking to other clients like iPhones and Android devices and stuff like that. So now your response could be in JSON or XML or something. But in our little world right here, it's a web browser asking for it. And this guy, he only understands responses in the HTML and CSS format. Okay, and he also natively knows how to interpret JavaScript programs. All right, so no matter what magic this web server has to do to ultimately deliver this response, the web server always spits out HTML, CSS, and JavaScript to the web browser. That's what web browsers know how to eat, so that's what they must be served. Okay?
You're not worried about MIME type. We're not getting into MIME.
No, it's unimportant for here. We want to try to understand the world of things. But actually, MIME type. We'll talk about MIME type actually. MIME type does not impact this.
No.
MIME type impacts the magic that's happening over here. So if this request came in and says, give me index.html, the web server is just going to go look up a file and serve it because it's already in the right format. But if he gives you a PHP document, now this guy says, okay, well, the MIME type is text/PHP or application/PHP, so now I need to pre-process this with a PHP module, ultimately producing HTML, CSS, and JavaScript. Okay, I got to send it into the kitchen. It's a special order. Okay, it's kind of what's happening there. All right, so let's kind of keep cooking with this, pun intended. Yep, go ahead.
How do you categorize like PHP or SQL Server?
You categorize.
Because you said programming language, like presentation language.
Okay. I think I'm going to end up answering your question. Okay, PHP is a programming language, 100%. What was the other one you said?
MySQL or SQL
Those are database management systems. Those are pieces of software. They're not languages. SQL is a query language. I would say it's more like it's a data representation language. It represents the nature of a database query. It's not a programming language. Doesn't have loops. Doesn't have conditionals. Doesn't have variables. It's more of a structured way of talking to a database. But MySQL, Oracle, SQL Server, these are all pieces of software that are database management systems. All right, so this web browser, from a development perspective, just to kind of understand the world we're in here. Now, first of all, one thing I'll throw out here is the stuff we're talking about right now actually is not what we're going to talk about in this class. I'm going to be talking about desktop programming using Java as our language. What we're doing today is we're understanding the entire world of software development so that we can then appreciate the little part of that world that we're going to be operating in. Okay, so hopefully when we come out, a lot of those questions like you just asked are going to be demystified. We're going to understand what kind of little pockets these different things fall into. Make sense? All right, so web browser. This guy is our, well, we're going to call this client side. The web server, we would call this guy the server side. Similarly, instead of client side, we could call this front end. We could call this back end. So when somebody says, I'm a client-side developer, or I'm a front-end developer, they're talking about I write software that runs here on the web browser. When somebody says, I'm a server-side developer, or I'm a back-end developer, they're talking about them writing software that runs on the web server. That means this software ultimately has to output this kind of message. Okay? This software ultimately outputs to the end user. Pretty pictures and text with some actual information stuck in there. Okay? So the audience of the front end stuff is the human, the person who's using the web browser. The audience of the back end stuff is the web browser. That make sense? Well, that's all kind of gluing together. All right. So client side technologies are HTML, CSS, and JavaScript. All right. Now, our evidence that HTML and CSS are not programming languages? Well, JavaScript exists on the web browser because HTML and CSS can't do programming logic themselves. JavaScript is what adds the dynamic logic to HTML and CSS. If you want something to dynamically happen inside of a web page on the web browser side of things, HTML does not possess the ability to handle variables, conditionals, or loops, or functions in order to do that. That's why we need the helper JavaScript in order to accomplish some of those things. All right? So let's talk about some of these server-side technologies then. Okay. I promise you we'll get to Perl. I'm going to leave it off this list for now because it's dead. At least from a web programming perspective. So web server, we're going to throw PHP here. I'm going to throw Ruby here. I'm going to throw Python here. And I'll throw another buzzword nobody mentioned, but maybe some of you have heard of, Node.js. How many of you have ever heard of Node.js before? At least like as a buzzword, they saw it. It's like all over the place today. None of us have seen it? All right.
Like JavaScript, core Java.
Well, the JS does stand for JavaScript, but we'll talk about that. All right, so potential server-side programming languages will be these guys. Okay? Now, in this case, actually, Node.js isn't a programming language. It's a framework. The language itself that's in there is JavaScript. That would be the actual programming language there. We'll expound on that here in a few minutes. But otherwise, possible back-end technologies, possible server-side technologies might be PHP, Ruby, Python, or let's just say Node.js for right now. So when this web server receives a request, something he mentioned a few minutes ago was this idea of a MIME type. Okay? MIME type basically says, what kind of file is this? If the file extension is .html, its MIME type is text/HTML, and the web server then gets notified that it looks at it and says, oh, its MIME type is text/HTML. All I need to do is find the file he's requesting and send it to them. I don't have to do any extra work. But if the MIME type is something else, like a PHP document, or a Ruby document, or a Python document, or a JavaScript document, the web server is going to notice it and say, oh, wait a minute, I can't just serve this because ultimately I need to send out HTML, CSS, and JavaScript. Because the MIME type is not text/HTML, I have to do some cooking over here. I have to send this to the right helper in order to get it into this format. So if it was a PHP document, it's going to send it into the PHP module. If it's a Ruby document, it's going to send it to Rails. If it's a Python document, it's going to send it to Flask. If it's a Node.js document, it's going to send it to something called Express. Okay, and we're going to talk about those here in passing. Okay. So bottom line is, in terms of the technology, in terms of the problem it's solving, all four of these are equivalents. And they are four different languages that all solve the same problem. And it would be fair to throw Perl into that equation. We'll talk about it on a different slide here in a few minutes. And it would be fair to throw a lot of other technologies. We can throw JSP in here. We can throw ASP.NET in here. We can just keep making a list. But I'm going to just work with these four.
So we use these same set of languages in the front end as well?
Nope, front end, HTML, CSS, JavaScript. Done. You can make an argument that Flash lives on the front end, but technically Flash is a third-party application. HTML5 is kind of it's HTML plus Flash, kind of in one product, if you will. That kind of lives in the browser too, but it's not an incorrect statement to say front end means this.
What about XML and SQL?
XML? We'll talk about XML. XML would be, well, here, I'll talk about it right now. If our browser is the guy receiving it, if we're talking to a web browser, the output from the server would always be this stuff. Now, let's say that I had another application that was talking to my web server, and let's say this guy was an iPhone, another front end. So instead of my web browser being how I'm viewing this, let's say I had an iPhone app that talked to the web server. And the web server, it asked the web server, please send me the list of all my current clients. Okay, you have an iPhone app and it's for doing invoices or something like that. And you want a list of all your clients. You're going to send a request to the web server for your list of clients. The web server is then going to send that to you. Just steal this guy. And it's no longer locked in to sending it to you in HTML, CSS, and JavaScript. It was locked into that because your web browser only understands that stuff. Well, on the iPhone, your front end is not limited to this. On the iPhone, your front end is going to be Swift or Objective-C. You have, a native programming language to work with. So realistically, what you're going to do is you're going to probably send that information as XML, let's call that historically, or more modernly, you probably send it as JSON. So these guys are data representation languages. Just to give you a quick example of what they look like. Type something in there real quick so I can left justify this. So let's say I wanted to send a list of clients in XML. So XML looks like HTML. So I might say client /client name Mike. Let's see maybe phone number 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to copy this.
Difference though is XML allows you to declare what type of data you're sending.
Difference between XML and what?
And HTML is kind of, you're not really, you got to work within the long as you define.
Let's say sort of. Let me finish doing this, and I'll explain it. But I think you're right, but for maybe the wrong reason. So let's see. We'll see in a second here. 555. Okay, so this would be like an XML-based representation of some client information. Okay, so the server might hit the hit the MySQL database, pull out the 2 clients that the person who's currently using the app has, says, okay, well, he's asked me for some clients. I went and looked in the database, found the clients, and now I'm going to wrap them up in this structured format for him. So I can send that back over the internet. The iPhone app can then receive that, and he can then parse this, pulling out the individual pieces of information he needs. Okay? What's nice about XML and also JSON, we're looking at the equivalent in JSON, is it does not matter if I send the phone number first or the name first, because the tags surrounding it describe the data. Okay? This gives meaning to that data, as opposed to the historical way of doing this where, maybe before XML existed, we might have done it like this. We might have said, okay, I'm going to send you a 2 followed by a colon, followed by Mike, comma, 1, 2, 3, 4, 5, 6, 7, followed by a colon, followed by a Dave, followed by a 5555555. So I would send this proprietary string to the iPhone app. He would then know that because he had agreed with the server that, okay, I'm gonna split this first on colons, and I'm gonna see, oh, there's 2 records he's sending me. Okay, the first record is delimited by commas. The first element is the name. The second element's the phone number. Well, that would mean that we cannot flip it over on this side, because that iPhone is assuming it's sending the stuff in the same order. Okay, so this would be a proprietary format that would require that the iPhone know the order in which stuff is being sent. XML does not assume that because it's described the data in here. Does that make sense? Okay, now the JSON, which let's call JSON the upgrade to XML. The equivalent XML would look like this, or equivalent JSON would look like this. The biggest difference is JSON supports arrays. So we have a collection of clients. So arrays are dictated by this, or notated by this square bracket thing. These are objects. So this is an object that contains a name and a phone number variable. This is an object that contains a name and a phone number variable, and here's the corresponding values for those guys. Okay? So it's all the same data that was in here, but kind of in a more streamlined format. Couple of advantages of JSON versus XML. One advantage is the people who are typically using XML or JSON are programmers. Okay? This is a pretty familiar syntax to programmers who are using C-based programming languages, and you'll hear the punchline about that here in a few minutes. Because I'm going to spend time today talking about the evolution of our languages, going from C to C++ to Java to C# to Objective-C and Swift, and then all the other languages on the website. So we're going to talk about a lot of stuff today. So this looks very C-like, so very familiar to a computer programmer. This, while readable, is very, very verbose. There's a whole lot of fluff to represent relatively small amounts of data. Okay, there's only 4 little bits of data here in all of this fluff. And also, XML does not directly support, well, not directly. XML does not support arrays. So if I want to represent two clients, I represented one client followed by a second client. Okay? So this would be our modern way of sending structured data to non-web browser based clients. So when we have these things called APIs. So if you went to the Weather Channel API, so if you have an application, whether it's a website or an iPhone app or an Android app or whatever, and you wanted to pull in the current weather for where you are, you might send a request from your iPhone to your application that you wrote on the iPhone would send a request to the the weather.com API, passing it your zip code. And then it would send back a JSON document with a whole bunch of information about the current weather conditions. Yeah.
Isn't a lot of that evolution due to the fact that, I mean, XML came about because it was a good way to send data in the format that you have it up there, but it was assuming that the recipient of that data knew how to interpret that information. So your program on the receiving end of it would need to know how that program's coming across and how to sort it and put it in a user viewable format to use it. So,
correct, but XML has a defined tag-based structure. We don't necessarily know what tags it has, and this is kind of what you were asking about before. Like for instance, in this language, we could immediately recognize that this is an XML format. Now, I have to know that this language implies that there's going to be a client, and there's going to be a name, and there's going to be a phone. I have to know to look for those things, but I don't have to worry about what order they come in because I am parsing, here's my opening tag, here's the corresponding closing tag. Here's an opening tag, here's a corresponding closing tag. So it's very consistent XML. Opening tags do not have that extra front slash, closing tags do have that extra front slash. So you can have a generic XML parser that could parse any XML document. Then you just have to know which tags you're looking for, what information am I looking for. So you can extract the name and the phone number, that kind of stuff. As opposed to, so let's say XML fixed this problem where it was completely arbitrary. There's no standard to this. So you and I could write an application and we can just, between the two of us decide, okay, well, we're going to separate things by colons and then we're going to separate things by commas. Okay, we're going to do that. And then you and I might write a program and we decided, commas are stupid. So we're going to use question marks instead. So we have all these proprietary approaches for how we're going to represent our data, and this data representation is only going to work for our little program. The other one's only going to work for our little program. Everybody else, if somebody else is trying to access our data, they got to make a guess or read a bunch of documentation on the freaky deaky way we decided to represent our stuff. XML added a standard. It said, look, we're going to have proprietary tags. Maybe I have a first name, a last name, and a SSN tag that you're going to have to know about. I'm going to have to, advertise that to you that I'm going to have those tags. But you can count on there always being an opening tag and always being a corresponding closing tag. It's following the XML standard. So you can write a generic piece of software that can parse any XML document. It might not know in context what to do with the data it's parsing, but it can get the data. That make sense? Okay, so now let's go back to what you were saying before. There's a hierarchy to this. HTML came first. Okay, so HTML was the inspiration for XML. So when HTML came out, in the early days at the beginning of the web, when most of us think about the web, we think about web browsers. The internet's a little bit bigger than that, but let's just say HTML was that original web language. It was widely adopted. People ended up liking it. And then as the types of applications we wrote became more and more complex and we started seeing other things, we have two software applications that need to share data between each other, HTML became an instant inspiration. It says, well, the server shares information with the browser using this HTML tag-based format. Why couldn't we leverage something like that to share information between two applications? Fine, so in steps in XML. So now the question is, what is XML? XML is a little bit misleading. So it stands for Extensible Markup Language, whatever. But XML is not a competitor to HTML. That's the first important thing. XML is a tool for defining data representation languages. That's what XML is. It allows us to define data representation languages. So one thing that XML supports, and I think this is what you were talking about earlier, is at the beginning of an XML document we have a DTD that allows us to define the types of tags that will be found in there. It is not required, but it is allowed to be there. Okay? That gives the person receiving it kind of self-documenting information about what kind of tags you can expect to find. Doesn't tell you anything about what they mean, okay? But it does tell you what ones you can expect to find. Completely unnecessary because any XML parser can go through and spit back out to the screen all the tags that it found. Okay? Say, hey, here's the opening tags I found. Got to give me a little bit of information what you want me to do with them. Okay? But I received your information. Okay? For many of them, hopefully they're self-explanatory, right? So name, probably make a guess that we saw a name tag. It probably represents the name. Phone probably represents the phone, so on and so forth. All right, so XML is a tool that really defines that opening and close tag-based structure.
But what I was getting at before is the difference between my interpretation, my understanding of HTML and XML. HTML is defined. In order for me to render HTML, I have to work within a framework of defined tags. There's a system to it. You're always going to have an opening HTML, a body, paragraph statement, so on and so forth. And you have to close them. That's always going to stay the same. Okay. Whereas with XML, it's not. It's you can define what you're going to transmit in that.
Okay, fair enough. But understand that they're not competitors. So, for example, you could use XML to define HTML. So, in fact, there is a version. There is a thing called XHTML. Okay, and that is the HTML language described using XML. Most web browsers have a mode, an XHTML mode that's disabled by default. That if you turn on, a whole bunch of web pages are going to start looking bad. Okay, that says we must conform to the XHTML standard, which means perfectly written HTML. So what you're kind of talking about is before we had XML, there already existed this tag-based language called HTML, which might as well have been defined by XML. That said, here are the tags that already exist. Okay? The web browser has already given meaning to those tags. So just like I'm saying, if you send me first names and if you send me names and phone numbers, I can look at that data and probably figure out what it means. Or you could just tell me, all right, the names are the names, phone numbers are the phone numbers. Okay, so I want you to take the names and the phone numbers and store them in the database or display them on the screen or whatever. Well, the job of a web browser is to take that HTML and interpret it and turn it into pretty pictures and text. So you're right. When you're speaking HTML to a web browser, you are limited to what that web browser knows how to do, and it knows how to do whatever version of HTML it supports. Okay, so it has to use some subset of the tags that browser knows about. It could use any tag at once, but tags that it doesn't recognize, it's going to ignore. Yeah, because it doesn't know how to handle them. It's going to say, oh, I have an opening cat, an opening cat tag. That's great. It technically follows a HTML-esque parsing pattern, because it's an XML-based parsing pattern, but I don't know what to do with a cat tag. So instead of screaming, I'm just going to ignore it. Okay? And that's what will end up happening. And we've seen that if you take an XML document, if we take something like this, and we feed this to a web browser, it'll just spit this back out. Okay? The web browser will just show the XML. Sometimes it'll do some color coding for you for opening and closing tags depending on the browser, but it says, yeah, I'm okay with the format you sent me, I just can't interpret it. These don't have meaning. There's no semantics for me. Okay, so
That's where your dynamic content comes in with the JSON is now you're taking that a step further with the JSON is now you have that interface that if I send a request to that web browser and it's in a JSON format, it knows to now I got to pull this information, pull it or do whatever, and I can send it that way.
yeah, but I mean, JSON's not doing anything that XML can't do. I mean, these guys, what's missing in any of these, whether it's HTML, XML, or JSON, or this, let's call this Mike language. Okay, this is Mike language that I defined using XML. None of these guys define the semantics. If I look at this as a human being, I can make a pretty good guess at what this data means. Okay, but this XML document does not dictate what that data means. The receiving program is going to have to previously know what name tags and phone tags mean in order for it to do something appropriate with that information. Same thing's true with JSON. Now, I think what you're maybe saying is that it's not uncommon for the phone to make a request in JSON to the server, dictating the kind of information it wants. So maybe the phone is going to send a JSON request to the server and say, I want all records associated with this user ID. So it might form that information in JSON for that request. Fair enough. Okay, but this server still is going to have to look at that JSON, piece it out, and it's going to have to understand the way that request was put together. JSON doesn't dictate the meaning of the request. It just says the format in which the pieces are put together. So when we explode it out, we still are going to have to figure out what it meant.
The main change in the programming language to define the best programmers or those who can just define the program. Like program is so easy to understand, even the layman can understand what he wrote to the computer. That was
So I think the fairest thing to say here is these are literally evolutionary jumps from each other. This is the old way of doing it. We call that proprietary. This is the more modern and still reasonable. There's nothing unreasonable about this today other than the fact it's just too verbose. But so what? It takes up an extra 50 bytes. Who cares? This isn't wrong. It's a lot of fluff to pull off something that doesn't need to have that.
You're dealing with people's data connections at 50 kilobit.
Not anymore. Historically, that's probably true. Yeah, but I mean, when you're dealing with text-based data, that's nothing. You're never gonna hit your cell phone data cap because you downloaded a Word file too many times. Okay, you're gonna get it because you stream Netflix. That's where you're gonna hit your data cap, and that's a lot of Word files if you're hitting 2 or 3 gigabytes of stuff. So. Yeah, I mean, this really isn't the problem. That's not the reason not to do this. The biggest advantage of JSON is the arrays, realistically. And then also, since it's the programmers typically using it, this is a good way of accessing that data. It makes sense to programmers, I guess. Okay, but all 3 of these guys are really solving the identical problem. How do I package up data in such a way that I can send it as a chunk and have the other end receive it in a format that it can then split it back apart, rather than just send byte after byte after byte of data, and then hope the other side can piece it together. Okay, so I'm sending it almost like secret message. I formatted this text in a certain way so that you will know what it means, okay? And then it's going to have to pull it apart on the other end. So we either have to give it a separable format like this, where now you and I had to agree that we used colons and question marks. Okay, that's our secret little language, okay, just between you and me. Okay, where in XML, we didn't have to agree upon that. I said, I sent it to you in XML format, and that's enough. You're dealing with opening and closing tags, and you'll figure it out from there. Okay, because this way, it required me to also tell you what order you were going to receiving stuff in. The number of records, the first record, the second record, and here's the order the crap is in there, and that kind of stuff, where XML leaves less to the imagination, or less for us to secretly pass to each other. Where really XML and JSON, outside of the array benefit of JSON, which let's just call it a convenience, that's not a deal breaker type thing, XML and JSON are equivalents. JSON would just be the cool kid modern way of doing it. So if anybody is writing a new API today, we'll talk about RESTful APIs at some point just to kind of demystify what that means. But if somebody's starting a brand new API today, they would do all communication in JSON just because that's the right thing to do. If they're maintaining an older API that had already been doing it in XML, at some point, if they're adding enough new features to it, they might decide to transition to JSON. Many of them still allow both. Because really, I mean, any of this data is going to be put together by a preprocessor on that API side, and putting data into XML or putting data into JSON format is not difficult. At some point in here, remind me, we'll do an example in class once we get some programming under our belt. It's not a hard thing to put stuff into it's much harder for us to write this as a human and not forget commas and stuff than it is for us to write a function that will output data in this format.
Yes, sir. But most of the people, most of the organizations use like XML rather than JSON.
Not anymore. Yeah, anything modern, anything new is going to be JSON. Now, but like I said, there's nothing wrong with XML. Therefore, if you're a large organization, for a good example here would be Bloomberg. So I consult for a bunch of folks at Bloomberg, and I teach them Android and iPhone programming. And the Bloomberg API is a very old API. They've been sending data between applications for a long time because that's where they make their money. How do I send stock data, right? It's all XML because they've done it for a very long time and they have a whole lot of data points. And it would be a bear to rewrite it. And like I'm saying, there's nothing wrong with XML. It's just not cool. And Bloomberg doesn't care about cool. They care about dollar signs. And people pay top dollar for access to their API. Yeah, it's not an open API. You have to have one of their terminals.
That's like with anything, though. I mean, if you're gonna, if you're gonna do something, you're gonna probably do it in the latest fashion.
Sure.
Maybe that takes a lot more effort.
I'm sorry.
I think XML takes a lot more effort to define this like name tag than closing tag.
It's marginal.
No, it's not.
I'm really saying these are equivalent. JSON is the slimmer way of doing it, but there isn't a drastic advantage.
No, the computer's doing all the work for you.
That's it.
Yeah.
That's it. The only thing that suffers is the data connection, and let's call it less than 1% difference. Because this is not big data we're moving. We're moving textual-based data. The fact that 90% of our internet traffic today is from Netflix means that this is meaningless amounts of data.
I think it's going to come down. You hit it on, I think, a valid point. Like Bloomberg, they probably have a lot invested in it. They have a lot of customers used to using it a certain way and having that information brought to them a certain way. It'd be a difficult transition.
Well, sure.
XML.
Plus, those customers are not. The customers are developers who are using it, who don't have a problem. From a developer's perspective, XML, JSON doesn't matter. Doesn't matter. You just pass it to a different parser.
It comes down to how do you,
Yep.
you pointed out even at the beginning, how you determine how that proprietary information
Sure.
is coming across. You already established.
Here's an alternative example. So I consult for Uber. So we're familiar with Uber, the taxi. Okay, so I have a bunch of students for iOS and Android for the Uber world. And that is actually very supportive of, hold on, I need to disable that phone call. That's pretty related to what I said earlier about all these programming languages are the same. Okay, so I've been teaching in a lot of different languages for a pretty long time. And the thing is that Uber, their iPhone application, was written in Objective-C, okay, which was the original iPhone programming language. Well, if you're starting a brand new iPhone app today, you're doing it in Swift. That's their new cool kid language, right? Nothing's wrong with Objective-C. In fact, I might even still say Objective-C is among my favorite languages. But it's a little bit intimidating when you first jump into it because it looks very different, and we'll explain that probably after our break here today. But I'll tell you about the differences in these languages. All right? But the idea is that the people I trained at Uber, when they get hired at Uber, a lot of these are younger folks. They just got out of school, whatever, they're 22, 23. Their background is in Swift. They understand iPhone programming. They've been hired for the iPhone team, but now they're having to go in and add features to an Objective-C based iPhone application that they haven't worked with before. So I teach them Objective-C. We spend 4 weeks and we meet like once a week and they have some coursework I send them through and they learn Objective-C. It's not a big deal, but the point is Uber, plenty of money, right? They certainly have the resources converted over. If it's not broken, why fix it? They have a huge code base that's already in Objective-C. Let's keep it that way. So they write their applications in Objective-C, even though nobody in their right mind would start a brand new iPhone application in Objective-C, if for no other reason than any of the new bells and whistles stuff is going to have the most online examples in Swift. But They're the same language. You know, if I can look at Objective-C documentation and just convert it to Swift, it says the same thing. Just one of them uses curly braces, the other one uses square brackets. It's the same crap. Okay. So, you know, in that, with that in mind, the end user is none the wiser. When you're using the Uber app, you don't know what that was written in, right? Frankly, Objective-C is probably faster, to be honest. Swift tries to be too many things to too many different people, but regardless, the end user is not going to know what the base language is behind the scenes they don't care as long as it works, right? The developers, they're developers. These are professional developers. They shouldn't care either. Like, we're paying you to write software. You write software and you write it in whatever language we tell you you're writing it in. All right, and that's kind of that programming as a skill set thing. So these guys come in the first, 2 days when they're staring at this wall of Objective-C code. It's a little intimidating because Objective-C at a glance looks intimidating. But then once you look at it for a few minutes, you realize it's all the same crap that's there. That was the other thing. It just looks a little different. All right. Actually, it's probably related to some of the languages in here. So how many of you speak Arabic? Several of you? Okay, so from an American perspective, when I see Arabic written, it looks very intimidating because it's so foreign to my eyes, right? Okay, but it probably doesn't seem like that big a deal to you. She's looked at it her whole life. Okay, so it's kind of the same thing. I'm sure with some instruction, I could look at Arabic, and I'm sure it's just as elegant, if not, actually, Arabic's really a pretty language. I had a student who used to write little messages at the top of their paper. I think it was like a prayer or something like that at the top of their paper in Arabic, and it looks really nice. Yeah, I mean, it's like, yeah, it looked like squiggly lines to me, but it looked really, it looked impressive, is what I'm saying. So, the punchline is that it's easy to look at something and be intimidated just from appearance, when the reality is it's just like anything else. We're just ignorant of it, right? Okay, so that's kind of our XML JSON argument. Sure.
How SQL interacts with HTML?
SQL would never interact with HTML. If you were looking at this model, you would have a database. You would have a computer program. This computer program, let's just do it with a text thing, would speak to the database using SQL. So it would make requests to the database.
So is it server side?
Yeah.
Okay.
Yeah. So it would make a request to this database.
Okay.
So you're talking web-based?
Yeah.
It
Okay.
doesn't really matter.
Well, but from a web, I guess to help explain it, correct me if I'm wrong. From a web-based perspective, I would send an HTML request to the server.
Okay.
All
And
right.
the server
and the
connect
server
to is
would have use PHP
okay.
to interpret, send it to like a module, like he was explaining, interpret that request that you submitted,
Okay.
and then that PHP would have instructions on how to send an SQL or retrieve the SQL from the database in that regard.
So it's client with PHP to server, and server connected to database with SQL.
I'm drawing a picture of it here.
Yeah, he's,
So this whole part is
That-
then back-end part.
I'm sorry?
Like this whole part is like program and database system is like back-end part, back-end like server part. Sorry.
No, that's all right. It's just, database is just, it's just a silo. It sits on a server, right?
It's on
And
the
in order to
server.
interact it, you have to have some sort of client, either be a PHP client or a database management system, that anything that can interpret and send
Connect us with the
SQL
database,
commands.
yeah,
Yes.
and have a communication with it.
All right, so for instance, let's say this is an iPhone app. This iPhone app is going to make a request somehow. Doesn't matter what the format of the request is. We talked about all sorts of different ways we can format it. So give me client records. It's going to somehow send that request to the server. Okay, and it's going to do that in the context of some program. So it's probably going to be asking for it to run a file, maybe called gen client records.php, something like that. Okay, so it's going to
It asks with PHP.
it's going to request that document. It's going to the iPhone is going to say call this get client record.php
It
file.
doesn't have to be PHP.
Okay.
It's just using
Which is a computer program that's over here. This could be PHP, this could be Ruby, this could be this could be really anything.
Okay.
All right, so it's going to be asking for some program to run over here. So that's what this guy is here. So let's say it's a PHP program. It could be a Ruby program. It could be a Python program. Doesn't matter.
Okay.
This program is then going to receive probably maybe the owner ID or something like that. So the person who owns these clients, he's going to get that piece of information. The program is then going to talk to the database where all those client records are stored. Okay, so this is going to be our database management system. So the program talks to the database. It opens up a connection to the database. There's lots of different, there's actually tools that sit in between here for talking to a database. On the website, popular ones called MongoDB and things like that. But let's just say somehow this program establishes a connection to this database management system. All right. It makes the request at some level using SQL, maybe through a third-party tool or directly using SQL. So this program is forming a request. So this request is going to look like something like select from clients where owner ID is equal to 7, something like that. Okay. So this database is then going to process that SQL request, send back the response. That is the list of all of the clients associated with that owner. That program is then going to send that response, format that response probably into, well, if it was a web browser, HTML, CSS, and JavaScript. Since it's a iPhone app, maybe it's going to squeeze that stuff into some JSON, put it into JSON format. So it's going to take the response for the database, reformat it, let's say in JSON, so it's kind of prepared to be sent over the internet. Send it back to the server, who then says, okay, well, my preprocessor has done his job. You requested gen clients records PHP. That program did his work, did whatever magic he's doing back here, talking to the database, sent me his response, and now I'm going to spit the response back out over here in JSON, for example. The iPhone's going to receive the JSON, parse it locally, and then put it on the screen in a table view or something like that, so you have a list of clients. Okay, so this is where that database plays in. So the database is it's a place to store crap. Okay, that's where stuff is stored. This is the data representation language that we use to ask a database management system to retrieve some information or even put some information in. But it's our query language that allows us to ask the database for information, okay, in a structured way.
And the program, like example of the program, that program would be like, do you have any example for the program?
Well, I mean, I gave you an example here. It could be gen clients, it could be a PHP program, it could be a C program, it could be a Java program. Every single programming language that exists today will have a facility for talking to a database. Yeah, every single one is going to have either a built-in plugin within the language for talking to a database, or through a third-party plugin. Most of the Windows tools use something called an ODBC connection, which provides a connection between a programming language and the database through the operating system. But every single 100% of programming languages can establish a connection with a database.
Thank you.
All right. I suppose if you get kind of unique enough into databases, you might run into some problems. But any database you've heard of, MySQL, Oracle, SQL Server, DB2, PostgreSQL, these are all popular databases. If you find Bob's database written in Brazil or something, it's possible that that there might not be a standard driver for it, but generally speaking, any programming language will know how to talk to a database. And it will always, our modern databases always are spoken to using SQL. We've actually upgraded these, so relational databases are kind of becoming old, old. So now we're using these things called data stores. So usually in conjunction with cloud computing platforms. So no longer are you actually talking to them directly through like an SQL. Now you're actually talking to them through an API provided to you by the cloud computing platform. So for instance, this could be Google App Engine or Amazon S3, or the one I like is something called parse.com. So parse.com provides an API for a whole bunch of different programming languages. Any language you've heard of probably, that allows you to talk to their data store using their built-in tools. So it's even easier than using SQL, because SQL requires the programmer to form proper queries. So SQL isn't overly difficult, but it's not overly simple either. I mean, it takes an attention to detail to write the correct SQL query to retrieve the information you're interested in from the database, where some of these newer things maybe make it less error prone, something like that. But they're all the same thing. Store crap. That's what these two things do. They store crap. Okay. See, now does it make sense why I create a custom slide set for every class? we zig and zag all over the place.
We can just go through them again.
Well, I sell these on a per slide basis.
We already paid.
I didn't see any of that. All right. So let's see. We talked about data representation languages. We talked about languages. Okay, so that's kind of differentiating between those two. Here's XML, JSON. Talked about that. Talked about that. Okay. So let me then just do this. I'll start the next slide, and then we'll take our break, and then we'll talk about it. I'm going to kind of build a slide here. All right, so I'm going to create a hierarchy of our history of our languages that, let's say, a history of our important languages. That doesn't mean that every important language has ever existed is on here, but a decent sampling that kind of gets us from where we were to where we are today will be represented. So we have C to C++. I'm only on the native side right now, but you're right. C, C++, Java, C#. Basic? Yeah. On Apple IIe's or old PCs? Okay. Java, C#, blah, blah. Let's go over, let's go here now. Objective-C. I'll throw it right around there. Objective-C 2.0. Gotta love Apple and their naming conventions. Then we'll say Swift. And then for my buddy over there, we're gonna throw Perl in here. Then we're going to throw PHP. And then we're going to throw Ruby. Then we're going to throw Python. Then we're going to throw Node.js. And then I'm going to just haphazardly kind of float JavaScript out over here. We've kind of already talked about that, where JavaScript is kind of a support language on the web side of things. So I'm going to label these guys. So these are kind of our web languages, which we've already spent quite a bit of time talking about, but we're going to finish up. Let's think about that for a second. I might just finish it real quick and then take our break. Shouldn't take very long. And I call these our native languages. All right, so now having said that, let me just do something real quick. I'm going to take like 5 minutes, so we'll go a couple minutes past 8 before we take a break. We're going to spend after break talking about this side of the equation. Okay? So now what I want to do here, so we have PHP, we have Ruby on Rails, as my other friend said here. We have Python, and we have Node.js. Okay? I'm going to rewrite these guys a little bit. I'm going to say this is PHP on Apache. This is Ruby on Rails. This is Python on Flask. And this is JavaScript on Node. This is actually probably should be Express, but just let me roll with it this way. Okay. These are already positioned here in order of when they came out. All right. So Apache is a well-known enterprise-level web server. Okay, been around for a long, long, long time. A high percentage of web servers on the internet are running Apache even today. Nothing wrong with that. When we say PHP, when we say we're using PHP as our back-end language, server-side language, that mostly implies that we are likely running it on Apache. It could also imply that we're running it on IIS, Internet Information Server, which is Microsoft's product. But if somebody's running PHP on IIS, unless they can make a really, really, really good argument, they probably should not have their job. If they're using IIS as their web server, they should be using the .NET suite of stuff. Microsoft's stuff is good. It just locks you into using Microsoft stuff. Nothing wrong with that. If you're a Microsoft shop and you have a Microsoft web server, great. Take advantage of the fact that you have a really, really, really good infrastructure for writing web applications using really powerful languages like that guy. All right, so if you're running IIS and you're running PHP on there, probably you're an idiot, is what it comes down to. Make an argument. You gonna make an argument?
My argument is sometimes you have developers that insist working with PHP or that's all they know.
Okay.
So you have to accommodate some of those resources on there.
Okay, from what position? So you have developers. Well, okay, actually, let me ask you this. Is it that PHP, that your server supports PHP and that's all that's running on there? Or is it that your server runs .NET stuff but also has PHP installed so that some people can do PHP stuff?
Mostly ASP and .NET.
Then that's fine. That's fine. If you're running primarily PHP on an IIS server, that would be stupid.
Then you'd be, yes.
Yeah. So you're saying there are some situations where a PHP script might be beneficial, where most of your neighborhood is on IIS and most of it's on .NET. That's reasonable. But if you were running IIS as your primary server and PHP as your primary development language, you're not taking advantage of your technology. Okay.
Fine, as long as that's how you're clarifying it.
Yeah, that's fair. That's fair. If you were running PHP only on IIS and just not letting anybody do Visual Studio development on it, I mean, you're wasting the technology. Then the follow-up question would be, why not run Apache?
Yeah, why are you running that?
Yeah, I mean, if you're a Windows shop, take advantage of Windows Enterprise stuff all working together. You know, so many people demonize Microsoft for being crap, and they're not. Microsoft makes great products; they're just proprietary. So, if you're going to use Microsoft here, then you're forced into using Microsoft here. It's no different than Apple's ecosystem. It's the same crap. Just people like to demonize Microsoft and like to complain that Apple. It's weird. Apple people like to demonize Microsoft. Android people like to demonize Apple. It's like this weird, it's a big circle of hate or something like that. Okay, they're all kind of the same crap.
Life cycle of hate. Has to make all that stuff work regardless of whatever.
Well, right, but and that's actually an important point because isn't that the world of IT? IT is a thankless job. When you're doing your job, when everything's working well, no thanks, no gratitude. It's when stuff hits the fan and everything's broken, now you're incompetent. Right? Isn't that the world? The jobs like that are thankless. I mean, the same thing's true. I mean, I'm not a political person, but I mean, the last job anybody would want is to be president of a country, right? When everything's cool, nobody's saying anything. But most of the time, things aren't cool. So now you're incompetent. So it's a very thankless job, IT, especially on university campuses, because the biggest squeakers are the students, right? My video games don't work because this guy, you have to block all these ports to protect the security of the university. Yet your constituents, your users here on campus,
Playing constant.
I can't do the stuff I want to do, even though it has nothing to do with their education.
You're blocking, you're blocking.
Yep. So it's an interesting world. All right. So PHP, I'm going to say it's running on Apache. So this is the web server. This is the language. Ruby is the language. Rails is the web server. So Rails comes with a built-in web server. Python is the language. Flask is the web server. JavaScript is the language. Node or Express is the web server. Okay. So all four of these technologies, as I have them written like this, we can think of them as being relatively equivalent. Okay? Now, some problems with PHP. Now, first of all, the good news for us is PHP is a really good language. It was designed specifically for the web. And with that in mind, PHP has stuck around. And it came through a very dark hour. Now, I'm going to talk about here in a second. Yeah. All right, let's just keep rolling. All right, so in any case, so the problem with PHP right off the bat. In the early days of writing PHP on an Apache server, there was an IT skill set that was required. That is, I have to get the server set up, I have to configure it, I have to get the PHP module installed, I have to do all this stuff before I can even start developing. Okay, setting up your development environment was not a 5-minute task. Required some expertise and time. Okay, so it wasn't just a sit down and start doing stuff. Now that problem has largely gone away now with online hosting stuff like GoDaddy and things like that, where you go on there, you give them $5 a month, and now you have a turnkey PHP host that's running on Apache. Okay, so the problem is mostly gone on that side, but that was you got to consider that some of these other languages came into existence in the meantime. Okay, so PHP, we're going to say required an IT skill set to create the dev environment. Secondarily, PHP was not MVC compliant. And that actually did not make sense back then. That statement wouldn't have made sense until we introduced something else. And in fact, with that in mind, let's take a 15-minute break, because I'm about to get on to about a 20-minute soapbox. And this is a pretty important section here, and so is this design pattern section. And I don't want to rush through it just so we can get to the bathroom. So take a 15-minute break. Let's come back a couple minutes after 8:20 or so. I'll stop this recording, get it uploaded, and then we'll pick up there. Sound good?
Yes, sir.